Alright, let's look at the homework 11.3, problem number 6. Alright, so let's use the integral test to see if this series is convergent or divergent. Alright, so the integral we want to evaluate would be integral from 1 to infinity. Alright, so you just turn n into x, so you have x squared over 9 e to the 9x dx. Right? Since we have to use the integration by parts, I'm gonna go ahead and do the indefinite integral, then do the definite integral after that. Right? So let's evaluate this integral here. So integral, and I'm gonna write it as this x squared. Then you have a e to the, so e is sitting on the bottom, so I'm going to put the negative 9x power, right, with respect to x, right? So integration by parts. So I take the derivative of this guy, so you get 2x, and take the antiderivative of this guy, you get e to the negative 9x over negative 9. Right? So the first term, we multiply these together. Right? So you're going to get this. Right? So I'm going to write it as a negative. Right? There's a x squared over. There's a 9 on the bottom. And I'm going to write e to the 9x on the bottom. Right? Then I'm going to multiply this way. Right? So it's going to be minus, right? But there's a negative sign, so it's going to be plus. Then we have an integral, right? 2 over 9x, and e to the, actually there's another 9, so I'm going to have to put the 9 squared. Then you have e to the negative 9x dx. Right? Then we're going to have to use integration by parts again. So we take the derivative of this guy. We get the 2 over 9 squared. And again, antiderivative of that guy would be e to the negative 9x over negative 9. Right? So this is going to be equal to, so I'm going to go down here. Right? Then, so this guy, the first term, this is already finished, so I'm going to just copy this down. 9 e to the 9x. Alright, so we multiply this way first. So you have negative, right? And then multiply these together. Oh, actually, I think I might have messed it up. Oh, so yeah. This should be just a 9, sorry about that, and this is just 9. Alright, so 9 here and a 9 there, because we multiply these two, so it's just not 9 squared. Alright, if you multiply these together, you get 2x over, right, there's a 9 and 9, so that one's 9 squared. Then you still have e to the 9x. Right, and then we have a minus, right? Then multiply these two guys together. So it's there's a negative sign, so I'm going to turn it into a positive sign. Then you have an integral, right? 2 over 9 squared, and then you have a e to the negative 9x dx. Right? So we're almost there. So I'm going to just go ahead and copy this down. So you have x squared over 9 e to the 9x minus 2x over 9 squared e to the 9x. Alright, so last one. So we have, this is going to be minus 2 over 9 to the squared. But you can see that the antiderivative e to the negative 9, oh actually, since e to the negative 9, I'm going to put the e to the 9x here. Right, then there's a square and divide by negative 9. So it's going to be negative here, and then it's going to be cubed. Right, and so that's it, and then plus some constant c. All right, then I'm going to put those guys together. So everyone seems to have a negative sign, so I put the negative sign in front. All right, then taking a common denominator, so it looks like we have to have 9 cubed and e to the 9x. All right, then we have, let's see, so we have to multiply by 9 squared, which is 81. So you have 81x squared, and plus this you have to multiply by 9, so it's 18x, and this one you just have 2, right, plus some constant c. All right, so if you want to find the this improper integral, so all you have to do is, this is antiderivative, so we take the limit as t approaches infinity, since this is improper. Then antiderivative is negative 81x squared plus 18x plus 2 all over 9 cubed e to the 9x, and you're going from 1 to t. All right, then this is going to be, we have a limit as t approaches infinity. All right, if you plug in t, you're going to get the negative 81t squared plus 18t plus 2. All right, then you have a 9 cubed e to the 9t. All right, then plug in 1, so it's a minus, then negative sign, so it's going to be plus. All right, so if you plug in 1 here, so 81 plus 18 plus 2, so that's 20 plus 81, so 101. Then you have a 9 cubed e to the 9. All right, so we just have to evaluate this limit. All right, then what we need to do is we probably need to do the L'Hopital's rule here. All right, so if you if let t goes to infinity, denominator goes to infinity, and the numerator goes to infinity with a negative sign, so negative infinity. So we can use the L'Hopital's rule. So I'm going to take the L'Hopital's rule here. Right, then this is going to be, if you take the derivative, so you have a 9 to the 4th e to the 9t. Right, derivative of the top is 2 times 81, 162t plus 18. Right, and here we still denominators 2 goes to infinity and numerators 2 goes to infinity, so we're going to apply another L'Hopital's rule. So you can see that this is going to be 9 to the 5th power e to the 9t. Then derivative of that is 162. All right, then we know that where the limit goes. As t goes to infinity, only thing that's getting larger is the denominator. So this guy approaches 0. All right, so this guy is going to approach 0, and this is just a constant. So what you get is this is going to be 101 over 9 cubed e to the 9th power. All right, so this is a kind of weird number, but it's still a finite number. So therefore, this improper integral is convergent. All right, so we know that the by integral test, all right, this series from n goes from 1 to infinity, n squared over e to the 9n is also convergent. Right? Remember that the corresponding integral and the series converge together or diverge together. In this case, one converges, so the other one also converges. All right, so let's type it in. So it's going to be convergent, and submit for testing. All right, looks like we got this one correctly. All right, that's it. I hope that this was clear.